All right, guys, today we are going to be working on learning how to do scale drawings and also scale models. So first, let's start with scale drawings. What is it? It's proportional, and it's also two-dimensional, meaning it's a straight line. It's measurement of length between two distances, okay? So if we were to draw a scale drawing of a map or a route from Seattle to Wenatchee, just distance. This is as the crow flies, right? You're not staying on the highway, you are just flying directly. It would be about 140 miles. Now we know that this distance you're seeing right here is not really 140 miles. But if we were to count out the squares, we would notice that we have 14 squares here, okay? So we could say that this distance, one of those, equals 10 miles, right? Because we have 14 of them. So one square equals 10 miles. And on a map, you're usually going to see a key like this that tells you how much each centimeter, and here we could call this 1 centimeter, is equal to 10 miles. So we can actually draw maps, because if you had a map that was as big as the actual territory you were trying to show, nobody'd be able to read it, right? It has to be at a smaller proportion. Another example would be doing a scale drawing. You may have done a scale drawing of your bedroom, perhaps. I want you to imagine that you had a 12-foot by 10-foot bedroom, right? So we could say that each centimeter, 1 centimeter, equals 1 foot, right? Because each of these little squares would represent 1 foot in your bedroom. Now you might measure your bed and you might say, oh, my bed takes up 3 by, by 6 maybe? Maybe if you have a smaller one, it's 3 by 5. You could draw that there. Maybe you have a desk over here that is a 2 by 3 desk and you could draw a little chair there. If you ever play around with home design or Tinkercad or any kind of computer-aided drafting problems, you're probably used to seeing floor plans like this that are drawn to scale using the same proportion. So 1 centimeter equals 1 foot. So we know that everything here is proportional. You might see a door here, and they might show the door swinging in like that. Let's say, maybe you're really lucky and you have a couch in your bedroom, or just a big overstuffed chair that would fit there. And so you could draw a scale model of your bedroom as long as you kept your proportion the same, or your scale the same. So we could write this scale as 1 centimeter equals 1 foot. Okay, and then we would know that this is actually a scale drawing of your bedroom. Now let's take a look at a scale model. A scale model is again proportional, but this time it is three-dimensional. So it's going to have length, height, and depth. Okay? So it would look something like a cube. So if we wanted to build a scale model of your bedroom, we would have to get some cubes out and actually give it some volume. So it'd be length, height, and width, right? So if you lived in a room that was a cube like this, we would have to measure how long each cube is. So we would have to say this is 3/4 of an inch. And in real life, your bedroom was, let's say it's 9 feet long. So each of these cubes would represent 3 feet. Okay, and that would be our scale. So you have to have some kind of scale, and you can write it as a proportion like this, or you can stack it up. And if we were to stack this up, we would say 3/4 of an inch over 3 feet. And we could probably make that a little bit cleaner, but that's just a rough version of what that scale would look like. I want you to know that a scale model is three-dimensional, a scale drawing is only two-dimensional. So here, if you have a scale model, and let's say it was a monument, your scale model is 10 inches tall, but it's actually 100 feet tall. You could say your scale is 10 inches to 100 feet. But the difference, if you want to find a scale factor, is that you have to put them in the same units, okay? So we have to convert this into inches. So 100 feet, we know there's 12 feet in inches. So our conversion factor would be 1 foot is equal to 12 inches. Top and bottom, our units are going to cross out, and we end up with 1,200 inches. So we would have 10 over 1,200. And both of these are inches. Now we can simplify it even further and say it's 1 over 120. And this is our scale factor. So again, you can have, if we were to just go back to this part, you can have a scale with different units, but in order to have a scale factor, you have to be comparing them in the same units. Very important to make that distinction. So in this example from the book, you're going to find the missing dimensions. The scale factor is 1 to 12. So you are going to have to make sure that you have the right units here. If you're going from this side to that side, you're just going to multiply by 12. Inches, inches. That's pretty good. Here we have feet. So I would recommend if you divide by 12, know that your answer is going to be still in feet. Then you have to convert to inches. Or you might want to convert to inches first. Say 12 times 15, or I'm sorry, 15 times 12, and then you're going to divide by 12. Okay? So be very careful with those scale factors. Here you have 32 centimeters, but over here it's in meters. So you're going to multiply by 12 and then have to convert to meters. Now remember, there's 100 centimeters in 1 meter. Keep track of that. When you go from feet to yards, remember there's 3 feet in 1 yard. So it's not just going to be multiplying by 12, but you are also going to have to convert to the right units. Okay? Little extra stretch, but you can do it. Good luck, you guys. And remember, using scale factors and scale models and scale drawings is a great way to bring math into the real world. You're going to see it in maps all the time, and knowing actually how far it is to get from one place to another is really important. Have a great week working on this. Bye.